In this video, I'm using Excel for multiple regression. The file we have here, housing prices saved from JMP format into Excel. We have price as the dependent variable and all predictors. Under Excel Data tab, you should see Data Analysis Toolpack. If Data Analysis Toolpack is not available, go to File, Options, Add-ins, and then at the bottom of the screen, Excel Add-ins, you should see that. Click on Go, check Analysis Toolpack, and OK. It will show up under Data tab. In Data Analysis Toolpack, you have two different tools you'll be using for multiple regression: correlation and regression. So the first step is to run a correlation matrix to see if we do have any multicollinearity. So correlation, start, input range, click on this button and select the entire range of data. Clicking any cell, Ctrl A will select the entire data area. Data is grouped by columns. We selected labels, so check the labels. Input range could be in a new worksheet or somewhere in this worksheet. We'll go with new worksheet. Here is the correlation matrix between all variables. Pairs of variables show their correlation. So price with price or beds with beds, of course, they do have 100% correlation. So the correlation is 1. And then the pairs, for example, the correlation of beds and square feet is 0.728. Here we're looking for correlations more than 90% or 80% depending on the level we select. You can find 95% almost correlation between miles to resort and miles to base. Same thing with it in JMP. So this is a case of multicollinearity. One of the Excel features that can help us finding the numbers we want in a range is conditional formatting. So if you switch to Home tab, select the entire data, and under conditional formatting, highlight cells that are greater than 0.89. Here I type so that if there's any number exactly 90%, it'll be included. So that's the only number, correlation between miles to resort and miles to base. If we consider 80% as the level, then we can look at other numbers between 80 and 90%. So we will remove one of these two variables, miles to resort and miles to base. And as we realized before through JMP, they do have similar effect, almost similar effect on the response, which is the price. So we go back to housing prices, the variable set, and remove miles to resort. Select the entire column, right click the header, and delete. Now we can use regression tool. Under Data tab, Data Analysis, and Regression. Input Y range is the first column. So click on the button and select the entire column of price. For the X range, click the button and select all other variables, including the headers. We have selected the labels, and we're going to have the output range somewhere in this worksheet. So select output range, click the button, and click one of these cells. and click OK. So we do have the output. You can see the R-square and adjusted R-square. In multiple regression, we always look at adjusted R-square. 76% of the variations of price are explained by variations of all these variables. What's important for us is a p-value. We follow the same process we followed in JMP by selecting the largest p-value, which is the least significant factor in determining the price, and remove that. We'll continue the process until we have all significant variables. If we consider alpha level of 5%, then all p-values must be less than 5%. One of the features can help here is again conditional formatting. Highlight cells that are greater than 0.05. And what's the largest? 0.71 years old. So go back, years old must be eliminated. I will eliminate the entire column. Clicking the header to select, right click and delete. Better to delete the entire output and then continue. Go back to Data tab, Data Analysis, and Regression one more time. This window holds the last selection always. So the only thing that changes here is the input X range. Y range is the same, and the output, we can keep it the same. Label selected, so X range will be all variables but the price. And click OK. Go to the column of p-values. The largest p-value belongs to the least significant factor, and that factor must be eliminated. Again, if you're not sure about which one of those numbers is the largest, you can always use conditional formatting. After selecting the range of the data, we can select greater than 5%. We have limited number of options here. Obviously, 0.66 is the largest, and that's days on market. So we do remove all the output and remove days on market and continue our regression model. Data analysis, regression. We need only to change the input X range. One more time on the column of p-values. And highlight the large numbers. Well, the largest is cars, 0.566 p-value. The least significant factor now. So go back, eliminate cars. Clear the area. And run the regression model one more time. Under Data tab, Data Analysis, Regression is selected. Just click OK and change the input X range. Column of p-values, and we can see 0.59. Since the format of the numbers are changing, if you're not sure, always use the conditional formatting. In conditional formatting, you can use top bottom rows. For example, top 10%. It automatically selects the largest number since we do have less than 10 items here. So, beds. Remove the column of beds and clear the area. Repeat the process. Under Data tab, Data Analysis, Regression, we do select the X range. And click OK. Column of p-values. For the predictors, if you're not sure with all these scientific formatting, you can always check that with conditional formatting. Anything greater than 0.05 should have a different format. Nothing changes, so they're all less than 5%. And this is the final model. 4 variables are the significant predictors: baths, square feet, miles to base, and acres. And these are the same variables we get from JMP. How to use them for prediction? Well, we can enter numbers. For example, for a house of 3 baths and 2,000 square feet, 8 miles away from the base on a quarter-acre land. What's the estimate of the price? Well, these are the values of the variables, and we can use the coefficients. These numbers are the coefficients of those predictors. So the number of baths times the coefficient plus square feet times the coefficient, and we'll continue for all these factors. And of course, the intercept. And this will be the estimate of the price with the given values of the predictor.